So for example, when you're dealing with an inequality and the exponent for x is larger than 1, what you're going to do is you're going to write the inequality f so that you have a 0 so you want to write the inequality so the polynomial f is on the left side and 0 is on the right side. So in other words, just like when you go to solve a quadratic equation before you factor, you always try and get a 0 on one side. So you want to write it in the form of f is greater than 0, f is less than 0, or it could be f is greater than or equal to 0, or f is less than or equal to 0. So the trick is, again, you still want to get a 0 on one side, but you always want to make sure that the 0 is on the right-hand side. That'll make your life a lot easier when you go to find the solutions. All right? So just like you solve quadratic equations, you're going to factor. And you're going to determine at which expression f on the left side equals 0. So you're going to do your factoring just like you did for solving quadratic equations. Figure out where all your factors are equal to 0. These are called your critical numbers. So if it was an equation, you'd be done. Those would be your solutions. But because this is an inequality, we call those your critical numbers. What we're then going to do is what we call a number line test. So what we're going to do is we're going to take these critical numbers and we're going to separate the real number line into intervals. So you're going to draw a number line and you're going to plot those critical numbers on the number line. You're going to select a test number in each interval and substitute into the factored expression. And we're going to determine the sign. We don't need to know what it actually equals. We just want to know, would the number be positive or negative in each interval? If the value of f is positive, so if you plug your number in and you get a positive, then that means f of x is greater than 0 for all the numbers in that interval. So if one number is positive, they're all positive in that interval. I'll show you what I mean by that in a minute. If the value of f is negative, then f of x is less than 0. That means that if one number is negative in the interval, they're all negative in that interval. Again, if you have 0, if it's a less than or equal to, remember you include the critical numbers in your solution set. So by your number line test, we'll be able to find your solutions. We'll write your answers in interval notation. Remember, you use parentheses for your less than or greater than. You use brackets for your less than or equal to or greater than or equal to. So you solve these a lot like solving equations, except you have to do a number line test at the end. So for example, looking at number 1, x squared plus 8x is greater than 0. You already have your f on the left. You already have a 0 on the right. You always want to make sure the 0 is on the right-hand side. So now how can you factor x squared plus 8x? What can you factor out of this left-hand side? An x. So any questions? Can I factor any more? No. So now I'm going to set each factor equal to 0. So I'll set the x equal to 0. I'll set the x plus 8 equal to 0. What other? That's where I have. So now you can identify what your critical numbers are. So 1 has to be 0. When you solve this, x will be equal to what? Negative 8. So there's your other critical number. So those are not the solutions. If it was an equation, yes, we'd be done. But we're not solving an equation, we're solving an inequality. So any questions on how to identify the critical numbers? Now I'm going to do a number line. I'm going to plot my critical numbers on the number line, on the real number line. So here's 0. So where would negative 8 be? To the right of 0 or to the left of 0? To the left. Now, this is where you need to decide on your number line, are we going to put it open or are we going to put a closed circle? Look at your inequality. This is just greater than 0. So can it be equal to 0? No. So instead of doing a closed circle in the number line, I'm going to put open circles.
So both circles you determine by looking at the original?
Yeah. Okay, so any questions on how to set up the number line? Now, what does it mean, ladies and gentlemen, to be greater than 0? This is why you want a 0. Does it mean that we're dealing with positive numbers, or are we dealing with negative numbers? Positive. So this means that I want to know where all my values are positive. That's why you want to have a 0 on the right-hand side of all your inequalities. So when I go to do my number line test, I'm going to pick a number. You see how when I plotted my two critical numbers, I've divided my number line into 3 intervals. I'm going to pick a number in each interval and plug it into my factored form. All I need to know is what's happening in the interval. Are all my numbers positive or are all my numbers negative? So let's start with numbers less than negative 8. Give me any number less than negative 8.
Negative 10.
Negative 10. Could I have chosen negative 9? Yes. Could I have chosen negative 11? Yes. Any number less than negative 8. Never use a critical number, however, to plug in. So now if I plug negative 10, and again, it doesn't matter if I go back to the original or go back to the factored form, it is easier to use the factored form. So plug negative 10 in for x. Again, I don't need to know what the actual number is. I just need to know if it would be positive or negative. So if I plug a negative number in for x, I know that's going to give me a negative 10 times. What happens when I take negative 10 plus 8? Is that positive or negative? Negative. And what happens with a negative times a negative? That gives you a positive. So since negative 10 would give you a positive, what that means is that every number less than negative 8 would be positive. So if I plugged in negative 20, if I plugged in negative 30, all right? Again, you can plug your test number back into the factor. You can plug it back into the original. It's always easier, though, to plug. You don't even know what the actual number is. If you want to find the actual number, be my guess. But you don't have to. All I want to know is if it's a positive or negative number. So any questions on how I know this is positive? Now let's pick a number between negative 8 and 0. Any number you want. Negative 1. Negative 1 is always
Wait, sorry, my bad.
Yeah.
Oh, no.
Ones and zeros are always the easiest to work with. So now let's plug negative 1. Well, if I plug negative 1 in for x, I end up with a negative 1 on the outside. Times. When I add negative 1 plus 8, that gives me a what? Positive 7, doesn't it? And what's a negative times a positive going to give me? Negative. So what does that tell you? Between all the numbers between negative 8 and 0, all those numbers are going to be negative. Okay? Now let's look at a number greater than 0. Give me a number greater than 0. 6, 1, whatever you want. Zeros and ones are always easiest. So if I plug in, obviously, a positive 1 on the outside. 1 plus 8 would give me a what? Positive. So what's going to happen with all my numbers greater than 0? They're all going to be what? Positive. So that's the number line test. So now look at this. Remember, this inequality, I'm looking where I'm greater than 0. Remember what I said, if it's greater than 0, what kind of numbers am I looking for? Positive. So right here, all my numbers less than negative 8 are positive. So that's part of my solution set. All my numbers greater than 0 are positive. That's part of my solution set. So it's negative infinity to negative 8, and then 0 to infinity. So there is your solutions.
So because of
Positive. We need to tell us. Because when I did my number lines test, all my numbers, because when I did my test number 1, which is greater than 0, that's where I got positive.
So if it happens that x less than 0, then it would be
Yes, the negative 8 is 0. You'd be looking for negatives. Okay?
what is
All right, questions on that one?
the circle was, right?
Then you would just be using a bracket before negative 8 and before 0.
But how do you figure out if the circle is?
You go back to your original inequality sign. If that's an equal to, then you know it is. Okay? Let's look at number 2. First of all, what do we have to have on the right-hand side before we can start finding those critical numbers? We have to have a what? 0. So I'm going to add 12. So now I'm going to factor x squared plus 7x plus 12. So factors of 12 that add together give me 7. We're 4 and 3. So then I set each factor equal equal to 0. So x plus 4 equals 0, x plus 3 equals 0. So this will tell me what my critical numbers are going to be. So what are my critical numbers going to be? Negative 3 and negative 4. Which number is smaller? Negative 4 or negative 3? Negative 4. So I have negative 4 and I have negative 3. Now go back to your inequality sign up here. It's less than or equal to 0. So if it's less than or equal to, am I going to include negative 4 and negative 3 in my solution set? Yeah, so I'm going to put a closed circle. Any questions on why they're closed? Now, it's less than 0. So what kind of numbers are less than 0? Positive or negative? Negative. So solutions to this inequality are going to be where I have negative intervals. All right? So any questions? So now again, just like I did before, my number line is divided into 3 intervals. I've got to pick a test number in each interval. So I'm going to plug in a number less than negative 4. Give me a number less than negative 4. Negative 5. So again, if I plug negative 5 again, just plug it back into your factor form. That's the easiest one to do. Negative 5 plus 4 is what kind of number? Positive or negative? Negative. Times. Negative 5 plus 3 is a what? Negative. So what happens when I multiply a negative times a negative? That gives me a positive. So that tells me then all numbers less than negative 4 would be positive. I always do. So now I got to pick a number between negative 4 and negative 3. Unfortunately, you're going to have to pick a decimal. The best one to probably use is negative 3.5. This is why it's critical. We don't care what the actual number is. All I care about if it's going to be a positive or a negative. If I plug negative 3.5 in for x, negative 3.5 plus 4, would that be positive or negative? Positive. Negative 3.5 plus 3, would that be positive or negative? Negative. So a positive times a negative would give me a negative. So again, because negative 3.5 plus 4 is positive, negative 3.5 plus 3 is negative, and a positive times a negative. Again, I don't care about what the number is. I just want to know if I did multiply, would it be positive or negative? You can choose any number greater than negative 3. Even better. How about 0? You could use 0. You could use 1. You could use negative 1. Well, 0 plus 4 is positive, correct? 0 plus 3 is positive. So what's going to happen when numbers greater than negative 3? It's going to be positive. So here are my solutions then. The only solutions I have are between negative 4 and negative 3. So how would I write that in interval notation? So we what? Bracket negative 4 to negative 3. Okay? Questions on that? Guys, shh, questions. Questions on that one? Why am I looking for negatives? Because it's less than 0. That's why I wrote less than 0 next to my number line. Numbers less than 0 are negative. Okay? That's why you write right next to your number line, what are you looking for? Less than 0 or greater than 0, so you know exactly what you're looking for. All right, let's take a look at, we'll come back to number 3. Let's take a look at number 4. X squared less than 9. First of all, what do you need to have on the right-hand side? You need to have a what? 0. So what am I going to do? I'm going to subtract 9. Yeah, we'll skip over 3 for a minute. So now how do I factor x squared minus 9? That factors into what? X plus 3, x minus 3 less than 0. So again, I set each factor equal to 0. So then what are your critical numbers going to be? Your critical numbers will be what? 3 and negative 3. Now, what kind of circles am I going to put above negative 3 and 3? Open. Why? Because it's just less than 0. So if I'm looking at less than 0, what's going to be my solutions? Positive or negative? Negative. That's That's why I write that right away next to my number line, so I know exactly right away what intervals I'm looking for. So now I'm going to plug in a number less than -3. Give me a number less than -3. -4. If I plug -4 in for x, well, -4 plus 3 gives me a what? Negative times. If I plug -4 in for x, -4 minus 3 is a negative. So what happens with a negative times a negative? That would give me a positive. So all my numbers less than -3 then are positive. So you want to write your sign right above the number line when you do your check. Now choose any number you want between -3 and 3. 0. Zeros and ones are always the easiest to use. So if I plug 0 in for x, well, 0 plus 3 is positive. 0 minus 3 is negative. A positive times a negative is a negative. Plug in a number greater than 3. So a number greater than 3 would be a 4. 4 plus 3 is positive. 4 minus 3 is positive. So a positive times a positive is a positive. So any questions on how I determine the signs in each interval? Now again, refresh my memory. What kind of numbers am I looking for, positive or negative? Negative. So the only interval that's negative is between -3 and 3. Am I going to start with a parenthesis or am I going to start with a bracket? Parenthesis. So -3, comma 3. So any questions on number 4? Let's look at number 5. So again, ladies and gentlemen, what do I have to have on one side of this inequality? What do I want to have on the right? I want to have a 0. So subtract your 5x and I'm going to subtract my 6. So now I have to factor this. So slide and divide, or just do it whichever technique you use. If I do slide and divide, it'll be x squared minus 5x minus 36. So factors of -36 that add together give me -5 will be a minus 9 and a plus 4. Divide by your 6. Reduce your fractions. Remember, don't forget to reduce. If you're doing slide and divide, don't forget to reduce before you do your sliding. And the denominator slides, yep. So you should factor to 2x minus 3 and 3x plus 2. Thus, this is why you had your factoring with Euclid's. So now be careful, guys. When you go to find your critical numbers, you want to take 2x minus 3 and set it equal to 0. 3x plus 2 and set it equal to 0 to find those critical numbers. So when you solve 2x minus 3 equals 0, what's the critical number going to be? The critical number will be 3 over 2. When you solve 3x plus 2 is equal to 0, your critical number will be what? -2/3. Now just because your critical numbers are fractions, when you go to pick your test numbers, use pretty whole numbers. Don't use fractions. So again, when I plot these on my number line, obviously -2/3 is smaller than 3/2. Am I going to use open or closed circles above the critical numbers? Closed. Why is it closed? Because it's going to be the less than or equal to 0. Since it's less than or equal to 0, when I go to do my number line test, am I looking for positives or am I looking for negatives? Negatives. Again, identify that right away. So now you have -2/3. What's a nice number less than -2/3? -1. That's what I mean. Just because your critical numbers are fractions, you don't have to use fractions to do your check. So if I plug in -1 for x, well, 2 times -1 is 2. 2 minus 3 is a negative. 3 times -1 is negative. -3 plus 2 is a negative. And a negative times a negative is a positive. What's a good number to choose between -2/3 and 3/2? 0. So again, 2 times 0 minus 3 would give me a negative. 3 times 0 plus 2 would be a positive. So a negative times a positive would give me a negative. Now remember, 3 halves is equivalent to 1 1/2. So what's a good number bigger than 3 halves? 2. 2 times 2 is 4. 4 minus 3 is positive. 2 times 3 is 6. 6 plus 2 is positive. So I know this is positive. So then the only values, remember, you're looking for negatives. You're looking for less than or equal to 0. So my solutions then are going to fall between negative 2/3 and 3 halves. Am I going to use brackets or parentheses? Brackets. So any questions on number 5? Let's look at number 6. First of all, what do you have to have on one side? You have to have a what? 0. So what am I going to do? I'm going to subtract x squared. How do you factor x to the 4th minus x squared? Take x squared out. Can you factor x squared minus 1 any further? It's a difference of squares. So we can factor into x plus 1 times x minus 1. Yep. So you take x squared equal to 0, x plus 1 equals 0, x minus 1 equals 0. So then what are your critical numbers going to be? Your critical numbers will be what? 0, 1, and negative 1. What kind of circles am I going to put above the critical numbers? Are they going to be open or are they going to be closed? Open, because I want greater than 0. So if it's greater than 0, what's going to be my solutions? Positive or negative? Positive.
We have to do it 5.
We have negative 1, we have 0, and we have 1. So how many intervals have I divided this number line into? 1, 2, 3, 4. So pick a number less than negative 1. Negative 2. Well, no matter what, guys, when it is x squared, this is always going to be what? Positive, right? Because a negative number squared. So when I plug in negative 2, negative 2 squared is positive. Negative 2 plus 1 would be a negative. Negative 2 minus 1 will be a negative. And what happens with a negative times a negative? It will be a positive. Plug in the number between negative 1 and 0. So what's a good number between negative 1 and 0? Negative 1/2 or negative 0.5. Well, negative 0.5 plus 1 is positive. Negative 0.5 minus 1 is going to be negative. So a positive times a negative is a negative. Yeah, because if I square negatives or positives, it's always going to be positive, right? Because if I square a negative number, it's always going to be positive. And you don't have to, you don't want to, let's just do it really easy. Number between 0 and 1 would be 0.5. 0.5 plus 1 is positive. 0.5 minus 1 is negative. Positive times a negative is a negative. And then plug in a number greater than 1. A number greater than 1 would be a 2. 2 plus 1 is positive. 2 minus 1 is positive. And a positive times a positive is a positive. Remind me again, what's going to be my solutions is inequality. It's going to be, what am I looking for? Positive intervals or negative? So my positive intervals came where it was less than negative 1 and where it was greater than 1. Am I going to use parentheses around my critical numbers or brackets? Parentheses. So it's going to be negative infinity to negative 1 and then 1 to infinity. No, because remember, the intervals around 0 are both negative. That's why you also, some of you may have noticed, you want to say there's a pattern. Well, if I start off with this one positive, then they automatically alternate. That's not always the case. It only takes you 5 or 10 seconds to do the check on the number line. So don't be lazy and not check. Because don't always assume that it's going to alternate. They do it a lot, but not all the time. So any questions on how you can solve the inequalities algebraically? You also have to solve them graphically. Okay, So I want to be able to solve an inequality graphically. So for example, when I give you a graph and where I want to find the solutions, first of all, the critical numbers, you always want to identify the critical numbers. And when you're given a graph, the critical numbers are your intersection points. So when you're given a graph, you can still set up your number line test. Your critical numbers are coming from the intersection points. So right here and right here are my critical numbers. So one of my critical numbers is going to be a -2. What's the other one going to be? 2. Now look at your inequality. It's just a greater than. So would I use open or closed circles above my critical numbers? Open. So you look at the inequality to determine your open and closed circles just like we did algebraically. All right, now the big question is, so y1, I want to know where y1 is greater than y2. So notice on my graph, y1 is my parabola, y2 is my line. So here I'm just going to highlight y1 in my pink highlighter here. And then y2 is my line. So I want to know, where is the parabola greater than the line? So where, looking here, when I say that, I want to know where are the y values on my parabola larger than the y values on the line? Well, do you agree with me that from here to here, the parabola is below the line? Do you agree with the parabola? So where the solutions to this inequality is going to have to be, it's going to have to be here and here. That's where the parabola is above the line. So notice right here, between -2 and 2, that's where that parabola is below the line. So on my number line, none of my solutions can fall here. So my solutions then are going to have to be where I'm greater than 2 and where I'm less than 2. So that's where the number line can kind of help you. So then I now could write my answer in interval notation. It's going to be from -infinity to -2, and then 2 to infinity. It always goes back to your original inequality. If your original inequality is equal to, then it would be close, just like we did algebraically. All right, let's take a look at number 8. Yes, Graciela. Where it's above the yellow line. Because we want to know where is the parabola, which is y1 greater than y2. Let's look at number 8. So here I want to know where is y1 less than or equal to y2. So first of all, let's find the critical numbers. Those are from the intersection points. So what are your critical numbers? One of your critical numbers is happening where? -5, and the other one's happening at 4. Look at your inequality. It's less than or equal to. Am I going to use closed circles or open circles on that number line? Closed. And it is helpful to highlight these graphs in 2 different colors for some of you. Remember, y1 is my line. y2 is the parabola. I want to know, where is y1 less than y2? y1 is my pink. Where is my pink below the yellow? So you agree with me that the pink falls below the yellow right between what 2 numbers? Right between what? -5 and 4. Because again, we want to know, where is y1 less than y2? Or another way to look at this, where is y2 greater than or equal to y1. Wouldn't you agree that these are equivalent statements? So maybe it's easier for some of you if you switch it. Where is y2, where is the yellow above the pink? Right here. So my solution set's going to be a bracket, -5 to 4. Like I said, when we started this unit, you're going to have to be able to do things not only algebraically, but from graphs and in certain things tables. There's always 3 different representations to do things. So it's not just algebraically, it's graphically, and then in some cases will be tables, just like we did the composition. All right, so not only do you solve inequalities algebraically, but now also graphically. Let's look at number 9. So first of all, find your critical numbers. We want to know where is y2 less than y1. Well, here's an intersection, here's an intersection, here's an intersection. So what are your critical numbers? Your critical numbers are what? -1, and what else? 1 and 3. Am I going to use open or closed circles above the critical numbers? Open. So I want to know where is y2 less than y1, or where is y1 greater than y2, if that's easier for you. y1 is the cubic function. So where is y1 above y2? Well, y1 is above y2 right here, correct? You agree with me? That's where y1 is above y2. And it's also above y2 right here, correct? So those are your solutions. So my solutions are going to be from where? -1 to 1. And then from what? 3 to infinity. So it's going to be parentheses -1 to 1. And then 3 to infinity. So like I said, guys, some of you may find it easier to see the greater than the less than. So if you need to, you can always rewrite it. All right? So any questions on number 9? So now this one's a little different. Where is y1 greater than or equal to 0? What does it mean to be greater than or equal to 0? We just talked about that. Means where the y values are what? Positive. So looking at your x-axis, where are your positive numbers? Your positive numbers are going to be where? Above the x-axis or below? Above. So all this region, any part of the graph that's above the x-axis will be solutions. Because this is where all the y values are positive, below is negative. So where is it equal to 0? Well, where is it intersecting the x-axis? That's where your critical numbers are going to be. It's intersecting your x-axis where at? -4, -2, and 1. What kind of circles are going to be above the critical numbers of a number line? Open or closed? Closed, because it's equal to. So now you can see from my graph, where is y1 greater than 0? Where is y1 above the x-axis? Well, it's from here to here and right here. So it's going to be from -4 to -2, and where else? 1 to infinity. So we have -4 to -2, bracket 1 to infinity. It's so much easier than the equation. All right. So, ladies and gentlemen, your homework for tonight. All right, guys, remember, you have 4 graphs to do on page 13, and then you have some to do on the previous page if you're just doing algebraically. All right? So any questions about your homework due for Tuesday?
Alrighty.